Hey everyone, welcome to the CrowPanel ESP32 HMI Display series tutorials. In this lesson, I'll show you how to use CrowPanel to display the desired screen in ESP Home. What you'll need is a Raspberry Pi 3BB, 4BE, or even a Raspberry Pi 5, a screen that can connect to the Raspberry Pi, an SD card, and a 5-inch CrowPanel, of course. You can also use other sizes of CrowPanel boards. In this video, I will burn the Home Assistant image to the SD card and then boot it using the Raspberry Pi with the server as the Home Assistant server and the CrowPanel as a device in Home Assistant. I can access the server's panel from my phone or computer to control the CrowPanel and check its current status. Next, let's see how to operate. First, search for Raspberry Pi Imager to download the image burner tool provided by Raspberry Pi, which can help us burn the Home Assistant image to the SD card. After downloading, install it. Since the installation process is quite simple, I won't go into details. Once installed, open the Raspberry Pi image burner tool. Click Choose Device, find the model of your Raspberry Pi, and select it. Then, click Choose OS and find Other Specific Purpose OS. Look for Home Assistant in Home Automation, and you'll clearly see the Home Assistant option. We'll choose to install the latest version, 12.4. Next, insert the SD card into a card reader, connect it to your computer, and then click Choose Storage to select the SD card you just inserted. Take your time here to ensure you've made the right selection, as it will format the storage before burning. Finally, click Next to burn the image to the SD card. The process can take quite a while, so please be patient. Once the burning is complete, you'll see a prompt like this. Click Continue, and it will automatically eject the card reader. Now, all you need to do is take out the SD card from the card reader and insert it into the Raspberry Pi's card slot. Next, connect a working screen to your Raspberry Pi. I'm using an Elecrow RC77 LCD display, which is sufficient for this project. Finally, connect your Raspberry Pi to an Ethernet cable and a power source. Since this is the first time booting up the Home Assistant OS, it will initialize a lot of content, so it may take some time. Once you see a house icon appear on the screen and an IP address printed out, that means the initialization is complete. Based on the IP address above, we can access the Home Assistant management page, and the one below is the page to view the running status of Home Assistant. Now head back to your computer and enter the management page address I just mentioned in your browser. Since this is your first time accessing Home Assistant, it will download some necessary files and initialize in the background, so you'll need to wait for about 20 minutes on this page. When the system panel is ready, it will automatically jump to this page. We click Create My Smart Home and register or log in with the account on the panel. You can customize the account, but please make sure to remember the account name and password, or you won't be able to access the system panel. After filling in the information, click Create Account. Select your location, and it will fetch local weather information based on your address and display it on the panel. Then click Next and finally Finish to complete the registration. When you enter the panel, you will see an overview displaying the current weather information in California. After the system panel is set up, we need to connect it to the CrowPanel, so we need to install the S-Phone plug-in in Home Assistant. Click Settings. Find Add-ons here to enter the plug-in management page. Then click Add-on Store to enter the plug-in store. Search for S-Phone. Open the installation page and click Install. The installation takes a while, so please wait patiently. After installation, the page will refresh automatically, click Start to enable SFOAM. When SFOAM is running, the page will refresh again, and you can see Open Web UI here. Click it to enter the management page of SFOAM. Now, there are no devices. I'll first demonstrate how to add a CrowPanel ESP32 Display 5-inch board. Click New Device, then click Continue. Fill in the name of the device here, which can be customized, and then fill in the Wi-Fi that the device is connected to. This Wi-Fi must be on the same local area network as the Ethernet connected to the Raspberry Pi. After filling it out, click Next. Here, select the type of board. Remember to uncheck Use Recommended Settings in the lower left corner first, then click ESP32S3. Find Espressif ESP32S3 box. Select it and click Next. Here, the device has been added. Click Skip. You will see that the device is currently in an offline state because we haven't downloaded the code to the board yet to establish a connection with Home Assistant. Click Edit to enter the code editing page for the 5-inch device. You can see that the code is very short. We click Install on the upper right to download the code to the 5-inch board. Since it hasn't established a connection with Home Assistant yet, we need to use manual download first. Since it's the first time compiling, it will download many tool chains and resource packages required for compilation, which will take a long time, about 10 minutes. Please wait patiently. After the compilation is complete, such a window will pop up. Click SFOAM Web to open the burning page. Then go back to the compilation page. Click Modern Format to download the compiled binary file. After downloading, switch to the burning page and connect the 5-inch board to the computer using a USB-C cable. Then click Connect and select the corresponding serial port of the 5-inch board in the pop-up window to connect it. Next, click Install and select the binary file just downloaded. Then click Open and finally click Install, and it's done. If you are using a board with a version below 2.0, please press the boot button and reset button before clicking Install to put the board into download mode. Otherwise, it will remain in the offline state. After the burning is complete, close the message box and return to the SFOAM device page. You'll see that the 5-inch board is now in an online state. However, there's no display on the CrowPanel. So next, I'll show you how to display a panel for controlling lights on the CrowPanel using SFOAM. Click Edit to open the code editing page for the 5-inch board, then open the example code provided in the course files. Since I'm using a 5-inch board, I'll open the 5-inch example code for reference. Once opened, let's first take a look at the code on the web editor page. This section of code is related to connections, which we don't need to modify. What we need to modify is the part related to board configuration above. Open the example code, copy the platform-specific code into it, and then copy the framework-related section. Change the Arduino framework to the ESP IDE framework. Additionally, there are configurations related to PSRAM. After these steps, the board-related configurations are done. Now let's proceed to add the screen display and control sections. All this code goes under the captive portal section. I'll copy it all here. It's not much, just including fonts, images, switches, displays, and touch-related functions. If you look at the beginning, you'll notice red wavy lines under the fonts and images. Hover over them, and you'll see why they're marked as errors. The font file cannot be found. Next, let's place the font and image files in the specified locations. Remember to click Save before leaving the code editor page, or your changes won't take effect. Click Settings, find Add-ons, open the add-on store, search for Samba, and go to the Samba Share plugin page to install it. After completing the Samba Share setup, click Start. Since it's the first time installation, it will ask us to configure the username and password. Before running Samba Share, click Edit Config and fill in the username and password for remote access to Home Assistant files. After filling in, click Save, then click Info to return to the Samba Share plugin page and click Start again to launch it. After it's launched, open any folder, enter / and the Raspberry Pi's IP address in the path to access the Home Assistant files. If it's your first time accessing it, it will prompt you to enter the account and password you just set. But I've logged in before recording this course, so I can access it directly. Now first, navigate to the config folder, locate the W folder, and open it. This is where the SFOAM code and files are stored. Then copy the fonts and images used for the 5-inch board here and extract them. Once done, return to the code editing page for the 5-inch board, and you'll notice that the prompt about missing files has disappeared. Moving on, I've also created 2 switches. The first switch has pin 38, which corresponds to the GPIO port of the 5-inch board. I've connected an LED module here to control the on/off state of the light. The second switch is for the backlight pin of the 5-inch screen, so I've kept it in an always-on state. Next is the screen driver section. This part of the code is already configured, so please don't modify it. It includes pin definitions that need to be confirmed by referring to the hardware circuit diagram. You can refer to the content of the second lesson to understand the relationship between the driver code and the pins. After the display initialization, it will display an image on the screen. This image is the one I just placed in the SFOAM folder. Finally, for the touch part, I've used the OnTouch configuration. When a touch occurs, it will execute the following code, printing the touch coordinates and changing the LED state when the touch happens within a specified range. This allows us to control the light. Lastly, click Save and Install to flash the code to the board. Since the board is already connected to Home Assistant, we can choose to flash the code wirelessly. Just ensure that the board is powered on. After the upload is completed, you will see it start to print the log information of the board. When I try to tap on the screen, it will print the coordinates of the point where the touch occurs. Then, when I press the on or off button, it will turn on or off the LED just as the code intended. Now I'll demonstrate how to achieve the same effect when using a 2.4-inch or 2.8-inch board. Click New Device to add a new one. I'll demonstrate with a 2.4-inch board, so I'll name it 2.4N. Here, you also need to uncheck Use Recommended Setting and click on ESP32. Find Deny 32 Room 32, select it, and then click Next. Similarly, click Skip and then Edit to enter the code editing page for the 2.4-inch device. Next, find the example code provided in the course and open the one for the 2.4-inch display. The download link for the course files can be found in the description below the video. For the 2.4-inch and 2.8-inch displays, we don't need to modify the parts related to the board and architecture. We only need to paste the function-related code under Captive Portal in the 2.4-inch code. The same font is used, which we've already added to the ESP home directory, so there won't be any error messages. However, the images used below haven't been placed in the directory, so we need to add the images used in the 2.4-inch code to the ESP home directory. Besides using images, there are also switches that are similar to the 5-inch board, but note that the pins used in the 2.4-inch board are different from those in the 5-inch board. Additionally, in the 2.4-inch code, A sensor is added to get the current temperature and humidity of the environment. For touch and display, similar to the 5-inch board, control of the LED is also added. Now let's upload the image files required for the code to ESP Home and then upload the code to see the effect. Open any folder, log into the Home Assistant directory, and find the ESP Home folder. Then find the asset package required for the 2.4-inch code provided in the course files. Copy it to the ESP Home directory, extract the images and fonts, and you're done. Return to the code editing page. If you find any error messages under the file names, you can modify the code anywhere, and it will recheck the code and eliminate the error messages. Next, click Install to compile the code. Since this is the first time downloading the code for the 2.4-inch board and it has not yet established a connection with ESP Home, we need to choose Manual Download. It will take a long time for the first compilation. After compilation, follow the same steps as for the 5-inch board. Open the ESP Home web and then go back to the compilation page. Click Modern Format to download the compiled binary file. After downloading, go back to the ESP Home web. Connect the 2.4-inch board to the computer using a USB-C cable, then click Connect. Select the serial port corresponding to the 2.4-inch board and click Connect. Then click Install and choose the file to select the binary file just downloaded. Click Install to flash the binary file to the board. At this point, if you're using a board with a version below 2.0, you need to press and hold the boot button first, then press the reset button, and finally release both buttons to make the board enter download mode so that ESP Home can connect to it. After successful flashing, if you're using a board with a version lower than 2.0, you need to manually press the reset button to see the results. If it's version 2.0 or above, it will automatically reset. Then return to the ESP Home page, and you'll see that the 2.4-inch board has also successfully established a connection with ESP Home. Additionally, you can see the current temperature and humidity of the environment on the board and control the LED status. However, controlling everything only on the board would be quite boring. Don't forget, we've also installed the Home Assistant system, so I hope I can control the LED status and get temperature and humidity information on my computer and phone. Let's see how I do it. Click on Overview, then click on the pencil icon in the upper right corner. Next, click on the three-dot icon in the upper right corner of the small box, select Take Control, and click Take Control again. This way, we can modify the Home Assistant overview. Click Add Card to add a new card to the overview, choose to add a button card, and then look for the LED switch of the 2.4-inch board in the Entities to be the entity for this card. But you'll find that it's not there because we haven't added the 2.4-inch device to Home Assistant yet. It only exists in ESP Home. Click Done to exit the editing mode. Open the Setup page, click on Devices and Services, find the 2.4-inch device from ESP Home, click Configure, and finally click Submit to confirm the addition. After successful addition, you can find the entities related to the 2.4-inch device. Return to the overview and add another button card again. Look, now we can find all the entities on the 2.4-inch device. Here, I want to control the LED, so I'll keep it as it is, then fill in the name. Both the name and icon can be customized, so choose whatever you like. You don't need to configure the rest. Click Save in the lower right corner to save the newly added card. Next, click Done to exit the editing mode, and try to use this card to control the LED status. It seems to be working smoothly without any issues. Then, let's add a card to display temperature and humidity. Enter the editing mode, click Add Card, find Horizontal Stack, and open it. Here, Locate history graph and add it. Next, we only need to complete the information in this card. First, add the humidity entity to this card, then change the title to humidity and adjust the display interval. After that, modify the maximum and minimum values of the y-axis since it's humidity. I'll set it from 0 to 100. Of course, you can add multiple entities to a card. Let's also include the temperature entity. Besides modifying the card display by selecting options, you can click Show Visual Editor to edit the code. Once configured, click Save to save the new card. Now we can see the newly added graph card in the overview, but it seems like the interval I set is too large, so we need to reduce it a bit. Enter the editing mode again. Click Edit under the card you want to modify and adjust the interval here to something like 0.5. It might show an error, but it won't prevent us from saving, so it's fine. Click Save, and now we can see the updated data in the graph. Isn't it great? Besides using a computer, you can also use your phone to access this page to control the LED and query temperature and humidity information. Well, that's it for this lesson. If you find this video helpful, please remember to like and subscribe. It will be my motivation to keep updating. Thank you for watching, and see you next time.